Hey everyone, welcome to another paper review. Today we're looking at Jukebox, a generative model for music, which was released a few days ago by OpenAI. So the Jukebox is a model capable of synthesizing raw audio and music clips. And one particularly impressive feature of this Jukebox is that you can condition the generative process on features such as the genre of the music, the particular artist that you're most interested in simulating, as well as on the full lyrics that you want to be used when you generate a sample. And then this model is then capable of generating a song clip, let's say 60 seconds or 1 minute or 3 minutes or 4 minutes, a full song, which is going to contain not only the music, like the beat or whatever, the sound, but it's going to even have a singer potentially singing the lyrics that you input to the model. So very impressive that you can do this at all, I find. So how does this work? There's actually two main model types that they train to make this working. First, we have a VQ-VAE variational autoencoder model, which takes as input a raw audio clip, let's say 20 seconds, and you have three different encoders here, which operate on different resolutions actually of this audio signal. By the way, as a disclaimer, I have to say that I'm not an audio person, so if I'm saying something wrong, please don't kill me. So you have this VAE encoder which converts this raw audio clip into some feature vector here, and for the different resolutions. And you then have a decoder part of this VAE, which takes this feature vector, which is some discrete features learned, and you go back to the original audio clip in the same resolution. And this audio clip is the same audio clip as the input, so this is like an autoencoder style of model. And you train this VQ-VAE on a large amount of existing music. So they compose a data set of 1.2 million songs in different genres, I think mostly in English, 600,000 or so in English and the rest in other languages. You're going to have some songs having a singer, some songs will be, let's say, classical music perhaps as well. And you train this VAE like so, using 20-second clips. Then the second component is another model which is taking some information that you want to condition the generative process on. So as input, you're going to be taking the features like the artist, the genre, maybe some timing conditioning, as well as, very interestingly, they also accept lyrics as an input. So you can input the whole lyrics of a song or some new lyrics that you came up with. Let's say you were very creative and you want to generate some new song for your lyrics. So you can input that, and then you have a transformer style model that is taking this information and then is trying to predict the features learned by the bottleneck layer of this VQ-VAE. So you take this encoder and you then apply it to, after you have trained it, you apply it to all of your data to generate these features. And these features are then used to train this conditioning model here. And so this conditioning model then, given that you have some new lyrics, is capable of generating a feature vector similar to the one that the VQ-VAE decoder has been trained on, the decoder part only. And then you can input this to the decoder and you can generate a new 20-second raw audio clip, which is going to be using your input conditioning information. And obviously it's much more complicated than this because you have to do like a sliding window style approach to be able to generate longer clips, let's say a whole song. So what they do is they apply some windowed sampling here, where they generate a 20-second sample, and then they move, let's say by 3 steps over and over again to predict the next 3 samples and so on. And you do this until you reach the time limit that you're targeting, let's say 4 minutes. Here in this example, they're doing 75% overlap. So this is how this VQ-VAE and the Jukebox works. This is how it's done during inference. Basically, you apply first the conditional model to generate the feature vector, and then you apply the VQ-VAE decoder. I hope this gives you a brief overview. And for me, the most interesting part, obviously, as an NLP person, is the conditioning on lyrics. So for this, they actually first apply a alignment model to align the songs with the lyrics provided by the songs on the character level, such that you have the precise characters used for this particular clip that you're trying to train on. And you use this information to generate a feature vector for the particular audio clip. And so that's that. So let's look at the blog post, which is very cool and contains a lot of samples of different audio songs that were generated. So the first thing you can do with this model, you can generate completely new songs from scratch, given some unseen lyrics. And here we have some examples of songs generated in different genres like heavy metal, blues, rock, and also conditioned on particular artists like Rage Against the Machine here, or Frank Sinatra. So probably you're not able to hear this very well, but I would encourage you to go on the website to check those out. But one very cool thing you have on this website is also you have the visualization of the attention of this lyrics encoder model as it's moving and generating. It's focusing on different characters of these lyrics to generate the sound. And actually I gotta say that the quality is pretty impressive. So you're able to generate the melody as well as the singing, which is very much like Frank Sinatra here. So you're able to capture both the style of the singing and the melody itself. Obviously it's noisy a little bit. I mean, this is a very challenging problem. So you can see some artifacts like some other people singing like a little bit. It's not natural in sometimes. But it's pretty good. You can also do stuff like regenerating songs, which are part of the training dataset, to get like new versions of these songs. For example, here we have some hip hop song which is written by Nas, and you can regenerate a new version of this song. This works a little bit better probably because already the model has seen this audio before and the lyrics as well. So this could be they say that this could be also novel. You can also complete songs, so you could provide 12 seconds only of audio of a song and then ask Jukebox to complete the rest of the song continuing the same style. Or let's look at the other one. Yeah. Very, very cool stuff. And you can also just provide whatever random fun lyrics and get some song clips from those. They actually say that they generated some lyrics about deep learning, but I couldn't find. And actually they have also a sample explorer which contains a lot of different genres, artists, and different model setups, which is very fun to play around with. Yeah, so I think this is the main things that I wanted to talk about. And then finally, I've actually been playing around with this model because the authors provide a nice Colab notebook, which allows you to run the code straight away out of the box. And first thing that I noticed is actually, indeed, the model is very, very slow to run. I actually had to run here the small version of the model, which is only having 1 billion parameters only. And the full model that they train in the paper has 5 billion parameters. But here, because of the constraints of Colab, I had to switch down to the lower quality model. But still, even with this lower quality model, I've been generating a sample already now for 5 hours, and I think it's still not done. It's still, because there's a lot of, so generating a raw sample, which is in low quality, is taking only 1 hour, but then there's a lot of different models that are upsampling this to generate a high quality sample using this VQ-VAE decoder part. And this part seems to be taking a long time, like 8 hours, to generate the final high quality sample. But cool that you can run this already straight out of the box. So that's all I wanted to talk about today. In overall, this is a very interesting approach, which works surprisingly very successfully for generating raw audio clips that have not only melody, but even the singing is preserved, and you can even relate the singing to the lyrics. Obviously, the authors also comment that in terms of coherence of the whole song, there's some challenges. So some of the audio songs that are 4 minutes are maybe making sense on a local level, like the local quality is good, but in overall, like if you look at the song as a whole, I think some of the songs are missing like some of the typical elements of normal songs, like having a chorus, clearly identifiable chorus, and so on. That seems to be missing sometimes. And also, probably the quality can be improved much further, but already for this paper, it's actually, I think this is the first paper that is doing this end-to-end, so this is a very good result. So I'm looking forward to seeing where we end up with this. And finally, maybe I should say that this could be a particularly interesting tool for artists which can play around with lyrics with different subgenres, play around and generate different clips, and then generate rough versions of their songs, for example. They could use the clips to be inspired to come up with even better music. So that is all that I wanted to talk about today. Please like and subscribe for some new upcoming NLP videos.